Welcome students. In Unit 3 of Module 2, we discussed about what is hydraulic jump and its derivation for depth of jump and head loss in hydraulic jump. Now, let's revise those formulas and we will go for next topic. We know what is hydraulic jump. Hydraulic jump is nothing but sudden variation in its depth due to this is a diagram for a hydraulic jump. Here there will be sudden variation in depth within a short length. Okay, within a short length, depth of flow increases rapidly. Okay, that's why this flow is called rapidly varying flow. Here at section 1, depth will be very minimum y1. At section 2, depth will be maximum y2. At section 1, flow will be supercritical. At section 2, flow will be subcritical. Okay, so we discussed about this hydraulic jump derivation. In this hydraulic jump derivation, if I know y1 means depth at section 1 and velocity at section 1, v1, then I can calculate what is y2. y2 is nothing but depth at section 2, like that v2. v2 also called as velocity at section 2. Otherwise, if f2, otherwise if y2 means depth at section 2 and v2, velocity at section 2 given, then I can calculate y1 and v1. These are the problems which are mostly used, mostly asked in this unit. Okay, like that, that formula is y1 is equal to y2 by 2 minus 1 plus root of 1 plus 8 fn 2 square. Okay, like that, if y1 and fn1 given, I can calculate y2. Let's see that formula. These are the types of jumps. We derived this equation. Here is a formula. y2 is equal to y1 by 2 whole bracket root of 1 plus 8 fn1 square minus 1. Like that, y2 is equal to y2 by 2 root of 1 plus 8 fn2 the whole square minus 1. Okay, by using these formulas, I can calculate either y2 or y1, depends on data given. Okay, then here we discussed about losses, and for head loss we derived a formula HL is equal to y2 minus y1 the whole cube divided by 4 into y1 into y2. Okay, this is length of jump formula. Length of jump is nothing but 5 to 7 times the depth of the jump, height of the jump. Height of jump is nothing but y2 minus y1. Okay, now let's discuss about salinity. What is mean by salinity? Okay, surges. Surge, first we will know, discuss about what is surge. Surge is nothing but sudden change in flow. It occurs when, if for example, if for our dam, waters are stored up to particular height with the help of shutters. Okay, here that is called sluice gate. If that is suddenly opened, then there will be a huge amount of water go through that sluice gate or shutter. So that causes the sudden variation in its depth. Okay, like that, if while closing the shutter also, if shutter is, for example, if I am opening the shutter, then water storing in upstream side, that means water storing side depth decreased suddenly, and in downstream side, water river side, water depth will increase suddenly. If shuttering is closed at that time, upstream side, that means water storing side, water increases suddenly. Like that, in downstream side or river side, water depth decreases suddenly. That is called surge. So surge is nothing but the sudden closure of gate produces positive surge, whereas a sudden opening produces a negative surge. We will discuss about this later. First, what is salinity? Salinity is nothing but there surge, we know what is surge. Surge is nothing but just like a wave. Okay, so velocity of that wave is called salinity. Salinity of surge is defined as the relative velocity of wave in a surge with respect to the fluid in which it is traveling. Okay, now, okay, what is wave salinity? I discussed surge and wave both are same. Okay, waves are formed due to air, I mean winds. But here the surge is produced due to sudden opening or sudden closing of shutters or sluice gates. Okay, wave salinity is defined as relative velocity of wave with respect to the fluid in which it is traveling. Okay, it is nothing but relative velocity. We know relative velocity concept is very simple. For example, if one bus is going with a velocity of 40 km per hour, if car is going with a velocity of 60 km per hour, then the person who is sitting in that bus will see the car is moving at a velocity of 20 km per hour, not 60 km per hour. So the difference between reference object and difference between moving object, that is called relative velocity. That difference between those velocities are called relative velocities. Like that, here water will flow in, generally normally water will flowing in river. Okay, if there is sudden opening or sudden closing, then there will be formation of waves. That wave may either move faster than that river normal river flow velocity. In that case, there will be a salinity, that means relative velocity formed. Okay, now let's discuss surge. This surge is nothing but open in open channel flow. It is considered as disturbance because sudden opening or sudden closing changes the water level in both river side and both upstream or storing reservoir side. Okay, now let's discuss about surges. Surges are two types. First one is positive surge, second one is negative surge. Then what is positive surge, what is negative surge? If see, a surge which produces a increase in depth is called positive surge, where surge which causes the decrease in depth is known as negative surge. Okay, now let's discuss. Okay, now if depth of water increases due to surge, then that is called positive surge. If depth of water decreases due to surge, then that is called negative surges. Let's see, here it is called positive surge because water is flowing at a velocity of v1 in downstream side. Okay, if I am opening a shutter, okay, I mean opening sluice gate, okay, at that time water will enter into the river with a higher depth. Okay, for example v2. So before opening the sluice gate, river velocity and river depth was v1 comma y1. After opening, there will be sudden increase in its depth y2 comma its velocity of v2. So here water moving direction is downstream side. So here, because of sudden opening, there is an increase in depth. So that is called so increase in depth towards the water flowing direction. This is called positive sludge. It happens when, means it happens when the sluice gate is suddenly opened. At that time, riverside depth increases, but on upstream side or dam side depth it decreases. So it is riverside diagram. So in this diagram we can see depth of water increases due to opening of sluice gate. So it is called positive sludge. Okay, it's already water was flowing with velocity of v1. Because of sudden opening, there is an increase in velocity called v2. So that relative velocity vw is called salinity. Okay, next positive surge moving upstream side. It's also called as rejection surge. It occurs when if a water gate, when water is closed, gate is closed or discharge is reduced. Okay, because of this, what will happen means, for example, water, if water is going in some river, okay, if I am suddenly closing that river, then what will happen? Water starts storing in upstream side. Because of that, upstream side depth increases, and it wave also moves in opposite to the flow direction. That is called VW. Here mentioned that as VW. Okay. Then negative surge. It is nothing but during sudden closure. If a water is suddenly closed at section 1, then what will happen at section 1? Its velocity, depth reduced suddenly. But on downstream side, there was normal flow happening. So their depth will be y1 and velocity will be v1. It is nothing but closing of sluice gate and river diagram. Okay, here section 2 is nothing but river, section 1 is nothing but sluice gate. If sluice gate suddenly closed, then its depth reduced suddenly. Okay, this is called negative surge. Okay, like that, this is another case of negative surge which happens in sudden opening of water. Okay, in dam, this is dam. 1 section is dam, 2 section is sluice gate. Okay, now let's discuss about problems. Here just read the problems. Water flow at a rate of 1 meter cube per second. Here discharge is given along the channel of rectangular section. Here rectangular section width is given 1.5 meter. So by using discharge capital Q and width, I can calculate small q, that is nothing but discharge per unit width, that is nothing but total discharge divided by width. Total discharge is 1, width is 1.5. If I am dividing both things, then I will get discharge per unit with small q as 0.67 meter square per second. I know for discharge unit is meter cube per second, for width discharge is meter, so then I will get a small q as 0.67 meter square per second. Then here critical depth is asked. We know what is critical depth formula for rectangular sections. Small q squared by g whole power 1 by 3. If I am substituting that, then I will calculate yc. Yc is equal to 0.356 meter. Okay. Then they are asking if a hydraulic jump formed at a point where the upstream depth is 0.2. Here upstream depth, that means y1 is given. Then what will be the rise in water level and power lost in the jump? Okay, here I know what is rise in water level. Rise in water level is nothing but called, we know because of hydraulic jump there will be increase in its depth. Okay, here y1 is given. By using y1, then how I can calculate y2? We know formula y2 is equal to minus y1 by 2 plus root of y1 square by 4 plus 2v1 square y1 divided by g. Either you substitute this formula, else just I know what is y1. I having y1 is equal to 0.2 meter. By using y1 and small q, then I calculate what is v1. Okay, I know v1 is equal to small q divided by y1. By using that, I can calculate v1. By using v1, I can calculate Froude number at 1. What is Froude number at 1? v1 divided by root of g into y1. If I am substituting that, then I will get a fn1, that is nothing but Froude number at 1. Either using Froude number and y1, then I can calculate what is y2. Here this formula is directly substituted in terms of velocity. If you don't know velocity, if you try this with a Froude number, then also we can get y2. y2 is nothing but in terms of Froude number formula, y2 is nothing but y1 by 2 root of 1 plus 8fn1 square minus 1. Here if I know y1 and fn1, then I calculate what is y2. Okay, if I substitute that, then I can calculate, I can get what is y2. If I know what is y2, depth of jump or rise in water level is nothing but y2 minus yn, which is equal to 0.58 minus 0.2 is equal to 0.38. Then I know what is head loss in pump. Head loss in jump. Head loss in jump is nothing but y2 minus y1 the whole cube divided by 4 into y1 into y2. If I substitute that, then I will get 0.118 meter. Here if power loss is asked, then we know what is power is nothing but unit weight of water times discharge times head loss. Okay, power, this formula is used in pumps and turbines. If I substitute that values, then I can get total P power is equal to 1.16 kilowatt. Okay, here this y2 is calculated based on different formula, that is nothing but y1 and v1. Instead of v1, we can calculate fn1. I am after calculating fn1, if I am substituting here, then I can get y2 also. I can get y2 in terms of y1 and fn1, or y1 and v1. Either in both case you can use any formulas. Okay, either you can calculate fn1 and substituting fn1 you will get y2, else by directly substituting v1 also we can get that y2 value. Okay, here let's see. As I said, I can calculate using Froude number also. Here it's an example for that type of problem. A sluice gate discharges water into a horizontal rectangular channel with a velocity of 12 meter per second. Here velocity given, depth of flow also given 1.2 meter. Okay, by using 1.2 and 12, I can calculate Froude number at 1. I know Froude number at 1 is equal to v1 divided by root of g into y1. I can calculate fn1 as 3.5. If you see this fn1, so surely at section 1 here flow number is greater than 1, so at section 1 always flow is supercritical. So I am ensuring here at section 1 flow is supercritical. Then they are asking for y2. If I know v1 and y1, I can calculate fn1. Then I know what is the formula for y2. y2 is nothing but y1 by 2 into root of 1 plus 8 fn1 square minus 1. If I substitute fn1 value and y1 value, then I can get y2. By using same formula, by same procedure, previous problem also can be solved by calculating Froude number at 1 and y2. Okay. Next, head loss due to jump. Head loss due to jump formula is, we know, y2 minus yn the whole cube divided by 4 into y1 into y2. If I am substituting y2 and y1 values, then I will get head loss. Okay. Here, another one problem, which is asked in universities. Here, by reading problem. Froude number before the jump. Here, before the jump, Froude number is given. Fn1 is given. Is 10. Hydraulic jump occurring in a rectangular channel and the energy loss is 3.2. Here energy loss is given, head loss formula, okay, is given. Estimate the sequence depth. Sequence depth means y1 and y2 comma discharge. Okay, here they didn't give anything, they give fn1. Now we know what is y2 formula for depth of hydraulic jump. y2 is equal to y1 by 2 into root of 1 plus 8 fn square. Okay, here fn1 value is substituted, then we can get a relationship between y1 and y2. I can get y2 is equal to 13.65 times y1. Here I am knowing the relationship between y1 and y2. Then another term, head loss is given. Head loss is nothing but 3.2 meter. Then here I am substituting head loss as 3.2 meter. I am substituting y2 in terms of y1. y2 is equal to 13.65 times y1. So instead of y2, if I substitute 13.65 y1, then I am converting that head loss formula in terms of y1. If everything is substituted in y1, then I will get y1 as 0.086 meter. If I substitute this y1 value in this y1 and y2 relationship, y2 is equal to 13.65 times y1, then I can calculate y2 also. y2 is equal to 13.65 times y1, which is nothing but is equal to 1.174 meter. Here y1 and y2 both are sequence depths. After calculating this sequence depths, discharge is asked. I know what is discharge formula. Discharge per unit width is equal to v1 times y1. I know what is y1, but I don't know what is v1. But I know fruit number at 1. Fruit number at 1 is equal to v1 divided by root of g into y1. Here, if I substitute y1 value and fn1 value, then I will get v1. If I get v1 by multiplying v1 with y1, then I calculate discharge per unit width. Okay. With this, I am completing third unit and its third module. Okay. If problems is asked in a third unit, mostly that problem will come with either these three models only. Okay. Most of the problem will come in these three types only. Okay. If you solve some previous year university question papers, you will get a clear idea about hydraulic jump. And if you have any doubts, you can refer books R.K. Bansal or Subramania, Open Channel Flow by Subramania, or Fluid Mechanics by R.K. Bansal. You will having a lot of problems in hydraulic jumps. Okay. Now again we revise what are the things we discussed so far. Here we discussed about what is surge. Surge is nothing but sudden increase in depth of water due to opening or closure of sluice gates or shutters. Here two types, positive surge and negative surge. In positive surge, depth of water increases in flow direction. In negative surge, depth of water decreases in flow direction. So the example for positive surge, here these are the four types of surges. Okay. Then we discussed about problems. In problems, either section 1 data, that means v1 and y1 given. By using that, we have to calculate y2 and v2. Else v2, y2 will be given. By using v2 and y2, we have to calculate v1 and y1. And if I know y1 and y2 both, then I can calculate head loss. If head loss is asked as in power, we have to substitute that in power equation. That is nothing but gamma times q times head loss. I will get a power. Okay. These are the three types of problems we discussed. Okay. In these three models, most of problems, if any problem asked in this third unit, mostly these three model problems will be repeated. Okay. There is no other chances. Okay. Instead of section 1 data, there will be a section 2 data. That may be the only difference for if any problems asked in this topic. So hope you understood this concept and try to solve previous year Anna University question papers. Okay, for getting better ideas. For objective type questions, you may refer any standard textbooks. There will be a lot of objective questions which are asked at the end of that books. Okay, at the end of book there will be a objective questions. In Subramania book also there is a lot of objective questions are there, and in R.K. Bansal book also there is a lot of objective questions are there. By using that questions, we can get some clarity about what is meant by hydraulic jump and surges. So with this I am completing third unit. Okay, I hope you understood that concept. And like this, for unit 4 that is turbine, for unit 5 it's pump. Both units also easy to understand, but for exam point of view, if you are strong in first 3 units, that is nothing but uniform flow, gradually varying flow and rapidly varying flow, then by using these 3 units itself you can easily score the marks. Okay, and you can particularly for civil engineering point of view, first 3 units are a little more important. Okay, pumps and turbines also important for us, but comparing to pumps and turbines, if we understood these concepts, this will help in your future subjects like water supply engineering and irrigation engineering. Okay, hope you enjoyed this, and try to solve some problems in previous year university question papers. Okay, thank you.